Welcome to all at examiners. This is the electronics and we are here for thermistor. In this lecture, we will see the basic thing regarding this thermistor, what actually the thermistor is, how many types of thermistor are there, and how it affects the circuit when it is used, what is the applications behind the thermistor, what actually the basic uses of the thermistor and the question related to the thermistor. So now we will see the thermistor principle, but before that thermistor principle, we must know what is thermistor actually. A thermistor is we can say a resistor whose resistance is depend on temperature. Okay, the simple thing, that is what we call thermistor. As the temperature increases, the resistance varies. We will see how it varies. Thermistor are used, if you see, it's commonly used in the temperature sensing applications. So if we see the principle, that how on which principle it based on, so temperature, it's a resistor. Thermistor is a resistor, and that depends on the amount of flow of current. As we know, resistor depends on the amount of flow of current. So resistor, we know simple thing, but when we talk about thermistor, it's a resistor, but it's a special type of resistor. Why it is a special type of resistor? Because it depends upon the temperature. Okay, so what happened with the temperature? Though we can say for the metal, in case of metal, we see the temperature, resistor increase with the temperature. For the metals, if we talk about, but the thermistor responds negatively, positively. So we have to see what negative temperature, what is positive temperature here. So main principle behind the thermistor is that we can say the thermistor decrease with the increase in the resistance. Okay, so with the increase in the temperature, so the resistance of thermistor decrease with the increase in the temperature. So this is the basic principle. Just remember, this is the core concept of the thermistor. See, actually thermistor is what a resistor, and that depends on the temperature. So it connects the electrical circuit to measure the temperature of the body. Okay, so it actually we can say it actually measures the temperature of the body and act according to that. Clear? So thermistor is used in sensors, heat sensors, you can say heating sensors, self-regulating heating elements. All these are the, we can say, the thermistor principles are used here, or thermistor are used here. Thermistor is what is a resistor, but is a special resistor. So it is made from a special material, and that is what? Semiconductor. Okay, semiconductor. You can see the different types of thermistor here. It can be spherical, it can be a large, a disc shape, okay, the square shape, whatever, even a rod shape, bed shape. Okay, so actually it's if we see a bead shape is what? Just like a pearl shape or bead shape. It's a few millimeter in diameter. You can say this is a capsule like also. But when we talk about the symbol of the thermistor, so this is, you can see the symbol of the thermistor. Okay, so this is the symbol of the thermistor. Now when we talk about the types, so as I told you, it's depend upon the temperature. Temperature can be negative, temperature can be positive. So it depends upon, rather than the temperature positive negative, it depends upon the coefficient, temperature coefficient. Actually you have studied that when the, you remember one formula, that if you want to find delta T, it's going to be 1 plus alpha delta T, or rather than this, R is equals to R naught into 1 plus alpha delta T. Here alpha is what? Your temperature coefficient. Okay, this is for the resistance. Clear? So when we talk about temperature coefficient, the thermistor mainly divide on basis of the temperature coefficient, positive and negative, PTC and TC. Now we talk about the PTC. This is a positive temperature coefficient. So PTC thermistor increase with the increase in temperature. Means thermistor, if I talking, it means resistance. Resistance increase with the increase in temperature. Okay, so it means it is directly proportional. So the formula is something like this: delta R is equals to K delta T, where K is your, as I told you, temperature coefficient. Just like alpha here, here K is the temperature coefficient. Okay, temperature coefficient, and delta R is change, delta T is change. Change in what? Delta is change in resistance, delta T is change in temperature. Now it's all about the temperature coefficient, so we have to see what about the K. Here we are talking about PT, so here K will remain positive. Okay, so PTC is actually the I told you, increase in resistance, thermistor increase in resistance as the temperature increases. So we have used this, we use this type of PTC, this type of elements in self-regulating body elements, overcurrent heating protection devices. Okay, so this is used in these ways. Clear? So PTC is actually a part of or one of the type of the thermistor. Just like there is one more NTC. But when we see the use of PTC, as I told you, is a circuit protection. Okay, prevent overloading, heat overloading. It's also used in televisions. It's also used in your we can say certain appliances which is automatically switch on or off according to the heat. For example, if you see iron, iron is what we can say. Iron is automatic. PTC is used in that. Means when it exceeds the heating limit, it suddenly cut off. Same way, there are many other things. For example, uh, you can say the water heaters. Okay, water heater is there. It suddenly cut off after achieving certain temperature. Okay, so after reach certain point of temperature, thermistors automatically switch off the appliance. Clear? So this was the application used. This is the application used for PTC. When we talk about NTC, NTC is what? Same thing, but here what happened? Here your thermistor decreases with temperature increases. Here what mean thermistor decreases?